we are going to look at making bond and breaking bond. We will take from the first one, making bond. Making bonds. Now, for you to make bond, energy is needed to be released from the system. That is making bonds releases heat energy. So when bond is made, heat energy is released. Hence, the process is exothermic. So the process of making bond is exothermic, and that is because heat energy is given out. Okay, so now we are going to look at bond breaking. Bond breaking. So that is breaking bonds. Okay, for you to break bond, in this case, heat energy needed to be absorbed. That is, heat energy is needed to be taken in for bond to be broken. So, can say bond breaking takes in heat energy. Bond breaking takes in heat energy. So we can say, hence, we can say bond breaking is an endothermic process. Okay, you can see that the two are opposite. To make bond, heat is given out. To break bond, heat energy is taken in. Okay, let's look at bond energies. Bond energies. Okay, so looking at bond energies. All right. So bond energies. Okay. Now, bond energy is the energy required to break or make bond. So So the energy required to make or break bonds is what we refer to as bond energy. Now, if you look at the table at the right hand corner, it shows different types of bond and the energy that is required to make them or the energy that is required to break them. The energy required to break or make bond are equivalent. Okay, and the unit is in kilojoule per mole. If you look at hydrogen to hydrogen single bond, you need 436 kilojoule per mole in order to break the bond. And if you look at carbon to hydrogen, you require 435 kilojoule per mole to break the bond. And as well as the other bonds as shown on the board, you can see their values. Now, what do we need all this value for? Okay, we need this value to calculate our change in heat energy. We need them in order to determine the change in heat energy during chemical reaction. So we are going to calculate our change in heat energy. Let us see how to calculate change in heat energy. So we are going to look at calculating change in heat energy. So, okay, calculating change in heat energy. Our change in heat energy is denoted by delta H. So, calculating change in heat energy. So, let's look at it. Change in heat energy is equal to energy taken in minus energy given out. So energy taken in minus energy given out. Okay, now when we talk about energy taken in, that is bond breaking. That is bond breaking. Like I said, the process is endothermic. Nice, endothermic. Then this is bond making. Bond making. This is exothermic. So if you look at this carefully, energy is taken in at the reactant, the left hand side. So this is reactant and this side is product. So from the equation, we have the reactant and we also have a product. So we can use this relationship to calculate our change in the heat of reaction. Okay, let's look at a particular example. Okay, I'm going to wipe this off. I'm going to look at a particular example. This is this oxygen. Okay. All right. We're going to look at the combustion of methane, the reaction between methane to form carbon dioxide and water. Okay. Now, so I can have the equation. Okay. So this is methane. This is methane. Okay. Plus 2 oxygen to oxygen. This will give us carbon dioxide. And water. Hydrogen to oxygen. Hydrogen to oxygen. Okay. So we want to calculate our change in heat energy of this reaction. First of all, we need to calculate energy taken in. So let's look at energy taken in. That is the first we'll calculate. Okay. If you look at the methane, you will observe that we have 4 carbon to hydrogen bonds. So we have 4 carbon to hydrogen bond. And our carbon to hydrogen bond here is that is 435. That is 4 times. We have 4 times 435. So you do some mathematics and give us the answer to that. You will have 1740. We're going to have 1740. The unit is in kilojoule per mole. That is kilojoule per mole. That is kilojoule per mole. The next one is oxygen to oxygen double bond. If you look at it carefully, we have 2 of it. So we have 2 oxygen to oxygen double bond. So we're going to have 2 times. Our oxygen to oxygen one is 498. That is 498. Okay. If you multiply this, you're going to have 996, and it is the same kilojoule per mole. So to calculate our total energy, so we'll calculate our total energy. Okay, so we are going to calculate total energy. The total energy will be 6, I have 3, I have 7, I have 2. So that would be the total energy. That is 2736. One side still in kilojoule per mole. So we are going to quote this value here, our total energy. Let's take down our total energy somewhere here so that we'll wipe this off. We have 2736. Okay, couldn't see that. Let's see it here. Okay. All right, let's take note of our total energy. All right. So our total energy is 2736. All right. So let's quickly look at energy given out. Energy given out. Okay. That is the product, as we said earlier. This is carbon to oxygen. And we have 2 of them. This is 1 carbon to oxygen, and this is 2. That is carbon to oxygen. So we have 2 of it. So we have 2 carbon to oxygen double bond, and our carbon to oxygen double bond is 803. That is 803. Take it like this. That is 2 times 803. We should be able to have 6016. So kilojoule per mole. Okay. The second part is oxygen to hydrogen. We also have 2 of that. This is 1 and this is 2. So we have 2 oxygen to hydrogen, and there is 2 in front of it. So 2 times 2 will give us 4. So we are going to have 4 into oxygen to this. Hope you get that right. There is 2 here. And then I have 1 oxygen to hydrogen, another oxygen to hydrogen, making 2. So if you multiply that 2 by this, you are going to get 4. Okay, so we have 4 times oxygen to hydrogen. That is 464. That is 464. If you multiply this, we are going to have 1856. That is 1856 is the same kilojoule per mole. Okay, 1856 kilojoule per mole. The same thing will calculate the total energy. That's a total energy given out. Total energy this is going to be 3462. This is going to be 3462. So kilojoule per mole. Okay, this our total energy 3462. Okay, now we have been able to calculate total energy taken in and then total energy given out. So for us to calculate our heat, change in heat of reaction is going to be the total energy taken in minus the total energy given out, as explained earlier. So let's look at that. So our change in heat is going to be our total energy taken in, which we calculated to be 2736. I said 2736. So we minus this from we minus energy given out, which is the last one we calculated, 3462. That is 3462. So our change in heat energy is going to be a negative value, definitely, because this is bigger than this. So we are going to have our change in heat energy to be minus 726. That is minus 726 kilojoule per mole. Minus 726 kilojoule per mole. Okay, so you discover that this is our change in heat energy of the reaction. So the overall reaction, that is the overall reaction is exothermic. Yes, number one, the reason being that the energy taken in is greater than the energy given out is greater than the energy taken in. So it makes us to have a change in heat enthalpy which is negative. And if you could recall, we said when change in heat enthalpy is negative, the reaction is exothermic. But in a situation where the change in heat enthalpy is positive, so the reaction will be endothermic. But in this case, our reaction is exothermic. So I'm going to be reposting the classwork you did in our last class. So I haven't gone through this video. You should be able to carry out the calculation properly. So see you in our next class.